Think I got it. This is probably my A. Yep. This is my model. Wow.
Take everything we got, give it an honest shot, turning it on and off, whipping and sliding, riding the highest dream, keeping the fire real. I call for you. Hold your gun, cut the wire, aim for fun with a light your fire. I've been flying up the ceiling, taken by this feeling. Maybe we're invisible at last. Fueling every engine, power is descending. Maybe we're invisible over the coming day.
Hi and welcome. So as you probably saw, I'm traveling a far distance and I'm currently here at Sinterit in Krakow, Poland. And it's super cool. I'm here to do like a video on how they're doing, how they're working. And I'm gonna follow my model from design to a finished print and post-processing. So it's gonna be super exciting working with these kind of tools here. We see the Sinterit printer machine. And the plan is to do like an on-site review. So I'm gonna test this. I'm gonna get into the details and show you as much as possible. Just for clarification, there is an NDA, so there might be some things that I can't show, but everything that you see is what I can see, can show. But more on that later. Now it's time to start the training and then we'll get into it. All right, so we're just gonna have a little bit closer look at the machine. I just had a small demo, so I know most of the things, but I'm gonna ask Robert here to fill me out a little bit later. So looking at the machine, it's a quite self-contained machine. It's kind of simple in its construction. I'm saying that with, of course, a little bit of irony because you have lasers in it, so it's not simple. It's rocket science. It's super cool. But if you look at the machine here, but we have a lot of heaters, and that is the main part of this system. You really want to keep the powders that are in these two beds. We'll talk more about that later. You want to keep them hot, because if they're not hot, they're not going to behave well, they're going to absorb moisture, they're going to just cause a lot of different problems. If you look down here in the actual build chamber, we have two volumes. So these are now, this is semi-risen, and this one is almost at the height of printing. So what's happening here is that this chamber is the printing chamber, and this one is the unused powder chamber. So this one will rise up to the needed height for your products. In this case, we got around 5 centimeters of maybe a little bit more that material that we will use. So later on, we'll just fill this up, just leave it like that. We don't have to measure anything, we just fill that up, and it's gonna, with this roller here, it's gonna roll off to the other side and building up our model, and of course, Sinter here with some laser. So if there's any unused material, it will keep in this chamber and you can reuse it later in this station here, which is the C. We'll talk a bit more about that later, but so looking at the site, we get some just power cords and plug, fan, emergency and USB port. So even though there's a Wi-Fi functionality on this machine, and what's interesting as well is that speaking of Wi-Fi and just looking at the machine, it has a lot of sensors. We see here, for example, 2 camera chambers. So these ones have both a like a visual camera, RGB, and a thermal camera in both of them. So that means that the machine has a full control over how the areas are exposed with heat, which means that they can apply these heaters really, really carefully to make sure that you heat the surface perfectly. So we can see here, for example, the mechanics of moving the roller is 2 wires. And that's also super good because, as you can see, there's some powder on the wires. And if you would have some kind of mechanics like a bearing or different rods, they would probably clog up with a lot of dust all the time. So this is a great solution to that problem. And the one roller here in the middle is actually something that's... and this up here is the laser department. It's actually a moving laser, so it's not a galvanizing laser. And reasons behind that is mostly simplicity, but also I think some patents and stuff like that. I'm not completely sure. But the benefits of having one of these lasers is that you don't have any areas on the outside of the print volume that are angled. So one of the key features to make sure that you get a really reliable print and have a really reliable printer, sorry, Swinglish, is that you keep the temperature incredibly exact. So I talked about the heaters in just a few seconds ago, but here's a practical example where we'll show how fast the temperatures are tracking. So you can see right now the room temperature here is around 27.65. It's changing a little bit. There's some air going around there. So you can see as soon as I put my hand inside the machine, it's gonna change the temperature here from, let's say, 27.8. It's around what it's right now in the room. But as soon as I put down my hand here, it's getting around 30.7. I have a little bit cold hands, so that's really, really cool. It shows how exact the temperature management is. But that's the overview of the machine. There's a window. We'll hopefully be able to see some prints on that later. So let's head in the software and start preparing our model. So the difference between SLS and SLA, or FDM printing, which you probably are familiar with today, is that in the SLS you usually have some sort of container or a compartment of powder which is unsintered. So it's just loose powder, just like flour really. And you then take this powder and you squeeze it out on a layer, roll it out, so you get a very, very thin layer. Just imagine like a sheet of paper, just like the thickness of a normal paper. And then you have a laser, so selective laser sintering. So you have the laser that adds energy and melts this powder just where you want to draw it up. So it's almost like SLA, where you have a UV laser and you draw everything that you want to cure. In this case, you draw with the laser everything that you want to sinter, so melting the particles together to a solid object. And that's the basic of SLS. I'm gonna have a very technical video specifically explaining SLS and other technology as well. So save that for later. But right now we are gonna move on to the next step, which is what to think about when drawing for SLS 3D printing. What are the limitations? What are the possibilities? So let's check that out. So one of the cool things about SLS 3D printing is that we have an enormous freedom of design. So we can actually create models that are not being able to be printed with FDM or SLA. So this means that we can use the powder as a support itself, and since we don't have to sinter all of the material, we can just swipe it away. So we end up having actually a built-in support using the unsintered powder in the model. So to try this out, I designed a pretty, well, it's a more or less of a testing model. We could have printed a benchy, we could have printed some other calibration model, but I thought that, hey, this is my video, I'm gonna make my own logo as a testing piece. So we have a few different parts on the model. First of all, the front is it's my logo, so it's a little bit more interesting. We have some really sharp edges that are difficult because they have a very small X and Y and also Z resolution. So I'm very curious about the sharp edges on the front and see how they translate going in and out of the model. We also have on the other side a very big little overhang, more or less. So that's also made to test that abilities. So when we print this with a normal FDM printer, we'll see some difficult parts about that. We also have inside a lattice structure that, well, it's not really able to build that without having some fallen down lines and everything. So using SLS, we don't have to think about that. We can use this Voronoi pattern inside my model without really risking anything. We also have some rounded parts as well and some stepping in different directions to see how it handles the resolution and the layer resolution. So I'm really keen to see how this looks, and I think all we really have to do is now take it into the slicer. And speaking of slicer, this is a very beta version of the slicer. There's already been released new versions since I got this version. But we have all the essentials. We can select resolutions, we can do some optimizations of the temperatures, we can change layer heights and everything. And these settings here are more or less if you're in contact with Sinterit and the technicians are helping you maybe fix an issue, or maybe you want to optimize something. So then you'll be able to adjust the temperatures just up and down a little bit, and also the laser strength if you, I don't know, if you try out some experimental materials. I wouldn't know. So all of these settings are probably with the newer versions packed even better. But again, this is just a slicer, you're not supposed to do a lot here. You can pack the models in pretty well. There's a collision detection tool because you can stack the models in top of each other in a way that you can't do with other 3D printing. So you don't have a limitation of like a build plate, you have a build volume. So everything inside here can be printed. There are some warning areas where you could see a defect of quality on the print, and that's due to the different temperatures being used. That sometimes you're not able to control the temperature as good, and that's why there's some yellow zones that can be printed in, but it's not recommended. So you can see all the zones that we can work with, but we don't always want to use all of them. So with that said, we just sliced it. You can see here some of the sliced files, and I think that's it. We don't need to talk about more of the software. It works, it does the job great, and there are some features I would wish for, and those might be coming. I can't tell you anything about that. So with that said, let's just jump into the next step, which is preparing the printer. Alright, so to load a model, we'll just click here, load model. And we can then choose from recent models or load new models. Well, since this is the first time I'm using a machine, we're gonna load from USB. And we can see here that we have our Sinterit 3D Print Tech Design SLS logo in S code. So that's pretty cool. It's not G code, it's S code. S is for super code. So you can see some things here. Remember to clean pyrometer windows and the glass protecting the laser before starting the print. So this is to make sure that they are clear from dust, and as you can see there, it could be a little bit sensitive. So just do it every time, and that will make sure that you have a great printing experience. So let's see, we are looking at around 11 hours of print time. We're using the PA12 smooth material, and that's it. So let's go ahead and clean all the windows. So now it asks me here, do you want to position the printer beds for your project? And absolutely, I want to do that. When we're doing this, as you can see here, the printing beds are moving. So the printing bed is moving down to home, I suppose. And the bed with the unused powder will then go down and let us know exactly how much we need to fill in. So we don't need to do any measurements or calculate how much we're going to print with. This will just show us how much, and that's going to be super easy to use. Alright, so it's time to load the machine up. As you can see, I put on some gloves and some mask. This is the recommended way of doing it, but there are some guys around me here that doesn't wear any masks. So I mean, it's not dangerous, but it's recommended. So we got a few tools here. I'm going to show you. We have a compressor, so this will be compressing down on the powder later on. We have a scraper to help cleaning out with some of the tools. And as I talked about cleaning before, we will clean all the glass surfaces after filling powder, of course, because, well, it's going to get a little bit messy here with some powder. And we also have, speaking of powder, the powder. So this is the PA12. It's going to be super interesting material. You can see here, it's really, really weird. I'm just going to get it in the camera here. Wow, it's behaves so strangely. Really, really cool. Okay, if I'm correct now, Robert, all I need to do is carefully pour this down. So I'm going to try not to pour it from too high, too far up. It's easy. Am I doing it too fast?
Okay.
It almost behaves like water when I pour it like this. Now this is a little bit too far up, so I'm going to move it down again. So strange to see it like pouring out like it's water or something. Super weird.
More.
Oh wow, even more.
All right.
Cool. Let's close the lid. Wow, it's almost like drips here. Now we're gonna start with the compression tool. Compress it down in here. Oh, that's weird. Wow, that's so weird.
More force. Yeah.
Wow. It's so strange. It's hard to explain how it feels. It's like you're pushing on water. No, not water, but it's like vanilla or something, because it behaves. It flows, but it's still solid. Really, really weird. Okay, I see. So you need to compress, and I can just put that there. Thanks. And then we'll just fill in as much of the material here out as possible. Make sure we keep it as dust-free as possible.
Yeah, just put more powder in. Right now, sift them.
Oh, okay, we need some more powder.
Yeah.
Cool, cool. I'm having the best teacher here with me, so I can make sure that I'm getting this correct. All right, so more compression? Or is it needed? No?
No. Right now, you just need to slightly distribute the powder. You don't have to clean anything right now. Because we will do that again. After the recoater will distribute the powder, we will do that again.
Oh, okay,
There will
okay.
be some powder on the backside.
All right, so the next step now is we're gonna start leveling. So the machine is now helping distribute all of this powder, and we have this chamber that I showed you before, So any excess that I filled up in here is actually going into that extra chamber, and so we can recover that powder later. So this step is pretty fun. It's like baking, but someone baking for you. All right, smooth. So it's now as smooth. Even if I fill it in, it's making it really smooth on the way back. Yeah, great. Okay, so I'm now just gonna swift a little bit of the extra powder that's outside of the machine here as well.
Yeah.
Just trying to get it like in.
Be more brave.
Be more brave.
Yeah, don't worry.
Okay.
Oh, perfect. Because recoater will level again.
Oh, okay. Like that, and then on this side. Okay.
So
yeah.
don't worry, you break anything or something.
That's good to know.
Yeah.
You heard it here first.
Yeah.
This is my proof in case I destroy
Pretty
something.
easy to use.
Yeah, okay. I get it now. It's just it's above the level, so you think that you're disturbing it, but it's actually like I get it now. So you can be. I understand what you mean with a little bit more brave. Cool. Would you say that this is good?
Yeah, perfect.
Okay, so it's now cleaning time. We've placed all the powder correctly. So what we now need to do is to clean the laser glass, and there's 2 screws here that we're gonna unscrew, and also clean the glasses down here. So we're gonna start off by making sure that we're holding this together and quickly unscrew these 2. You don't want to drop them in the powder, then we're gonna have a cool crater, like so. And then we'll drop this down, and we are able to just open this up. And then we have the glass surface here. So Robert, will you help me with the cleaning of this? So we're just gonna take out the glass and clean it and then put it back in again. Okay, so there we have it. It's now clean. Now all we have to do is to close this again, like so. We are gonna screw these parts in again. It's kind of cool to see all the details here. I'll show you in a second, but there's so many heating elements and cool parts. Okay, cool. So that is now correct. Let's clean the 2 windows here. I'm just gonna clean here with the surface, with the alcohol on both windows, and then we'll take one of the clean sides and just wipe off the alcohol again, so we don't leave any marks there. Super, that's it. And now we just have to shut the machine, and we should be ready to print. Ta-da! All right, so let's go. Let's go ahead and print. Well, obviously, the next step is very simple. It's just click start. There's sounds coming from the machine. That's a good sign, I suppose. All right, so what's happening now with the machine when it's starting to print is that it's also taking the recoater and making sure that the powder is even at both the distribution or the powder bed and also the build volume. So that's what's happening right now. And then it's gonna start to heat up the machine. As we said before, heating is super important to make sure to get a good print. And so that's gonna take like an hour or so, and we'll come back tomorrow and hopefully we have a really cool print to work with. So it's already the next day and the print is finished. Now, what's cool with this kind of printing with the SLS is, as I've explained several times before, obviously, it's really important to control the temperature. So during the night and probably somewhere around this morning, the machine would cool down for almost an hour as well to make sure that you can reuse as much of the material as possible. So the machine is here. I don't think we can see anything finished. No, we can't see any finished prints. But they should be somewhere in there, I hope. So in just a few seconds we're gonna take out the models. We're gonna load them on a special tool that we then put in a metal tray. So we're going to use some of these tools to make sure that we can clean the whole model and like get everything off. And when we're done with that, we're actually gonna go into the sandblaster and just clean out any of the like different difficult areas. Now I won't be able to run this machine here, but this is the, as I shown before, the sieve. So in here We'll reuse all the materials, it'll be in a new container and you can just feed it up in the machine again. So with that said, I think it's time we start with the post-printing and post-processing. Now, as you probably noticed, there was not a time-lapse of the 3D printing. It's very difficult to make a time-lapse of an SLS machine that's fully enclosed, so hopefully you can forgive me for that. But we'll hopefully see some cool results, and of course at the end of this video, or a little bit later, I'll show you some really cool examples I'm looking at. These are the ones that I can show. If you follow Sinterit later, they're probably going to show like a lot of new cool models. I can see them, but I can't show them. So let's enjoy the ride and let's get this print out of the 3D printer. It's now time to remove the print from the printer, and so I put on my gloves again and the mask because there might be some dust or some powder going around. Now we're going to use this tool, which is a pretty cool tool to remove the whole bed. And then we're going to move this over into this platform and unload it and start working with it. So the first step to do that is just to raise up the bed, and then we can attack this one. So let's go ahead and raise up the bed. All right, so I'm getting some assistance here just to push the button because I want to film this here. We're actually lifting up the so-called print cake. It's a fun name for it. But this is the powder that is being used during printing. And somewhere in here, my print is. Hopefully. And that's the end. So now it's time to take the tool, this one here, and just unload here. So I'm gonna go in here and I'm gonna go down with the right side. And then we are going to more or less just take this in like so. There we have it. Now we're gonna move it over to the bed where we'll clean the model. So take it over, get over, get over, get over. Carefully. All right, and let's see if we can. I wanted to have some nice pictures, but this is more like it. Okay, and now we are gonna start cleaning it. It's time to start digging. We are gonna get the fingers deep inside this here, and I'm really curious on how this feels. So let's get cracking. It's so cool. Oh, it feels so cool. It's super weird. I feel something. I think I got it. Think I got it. This is probably my A. This is my model. Wow. Okay, so I have some tools here with me. Could help a little bit. So we are now scraping off the unused material.
There is no need to be so gentle.
Yeah, okay. It just feels like you want to be gentle. But yeah, it's a strong print. I get it. And in here is the very complicated part, as you saw me design.
So we just put it to the blaster.
Yep. Just wanna.
It was a smaller one because the time of the print.
Yeah, so I kind of reveal here. Oh. Okay, so that's what we're gonna do here. Let's move into the next step, which is the sandblaster. Okay, so we're taking the print here, my beautiful A, getting it into the machine, opening this up, just putting it somewhere in there, close it up again, and then we are starting to blast it. Okay, so that's it. Something like that. Okay, so we're now done with the whole history here with the print. So we dug it out from here. We made sure to clean it. And would you just look at that result? It's really nice. Let me go get you some close-ups of this and some other models. And I think we can call this a success. I'm pretty sure this is the best print I've ever had. It's so smooth, it's so nice, the texture is so good, and it can handle all of the difficult areas. So let's check it out.
Don't push me any further to the edge, Just come into the wildlands of my mind,
Alright, so I think it's time that we start to summarize this video, but first I just want to show you how we can reuse the material, and I think that's really important to show because it can be used and reused, and it's really nice to do it. So check this out first. So it's important then to sieve the material. So we want to restore all the unused material here quickly. So all we need to do really is to pour. So you want to take the material and of course as carefully as possible pour it down into the machine. Whoops.
No, don't worry.
Don't spill too much.
Yeah, it's a powder.
As soon as we close the lid, it's now time to start the sieve. Alright, so then you just open up here and you have a fresh container of material. Now you can mix in some new herbs needed. If you run the flex filament, the TPU base, you don't need to do it. When you run with the PA12, you should add around 30%, I think is the recommended limit. So this is all ready to start printing. Alright, so that summarizes my whole experience with the SLS 3D printing system on site, hands-on, and it's been amazing. So you saw the model, it's really good. I mean, even the small areas that are difficult, they end up being no volume at all. And maybe you saw it, there was a little bit of mark there, and it's kind of interesting because the nylon or the PP12 material is super small balls, more or less, balls of nylon. So when you sinter them, when you end up being like the smallest possible sintering, you start to see these balls. Like it's the maximum resolution is of course the size of the nylon balls. So I think that, or nylon spheres. So I think that's really interesting. But other than that, it handled all the different areas. You can't really see which way it was printed, so there's no visible layer lines. A little bit on the front, and it could also be from scratching it a lot. And I mean, the quality is just super. And you have to remember that this is not like the normal nylon that you can print with some 3D printers. This is SLS fused nylon. So it's super hard. You can't even break it if you try. Of course, you can break it if you try to, but it's so super strong, and I think that is amazing. And it's heat resistant. You can boil water in these kind of stuff and so on. So it's the material types that you can have is super interesting. And speaking of that, I'm going to show you some examples where you use the flexible material as well, and you can see how cool that is. So we're just going to check that out. Alright, so first off we have this model. It's just freaking amazing. It blows my mind. I mean, check this out. You can even open it. You can scroll through the pages. And do you see how many pages there are on this small model? And it's all flexible. And it's printed in one part. That's just sick. I mean, that shouldn't just be possible. So yeah, wow, amazing. And this here as well. So the playing field here, well, first of all, the models are pretty cool as well, but the playing field is also made with a soft material, the Flexa material, of course. And it has this really strange feeling to it. It's much more fluffy, feels much more like a foam than like an actual plate. And I think I bent and cracked it there, but don't tell anyone. But yeah, everything is flexible. Of course, the smaller parts are more flexible than the harder ones, but yeah, it's just amazing. It's pretty standard, but really cool tire. So yeah, that's another application. All right, and there's a bunch of more models that we can show, and I'm just gonna play some music and I'm gonna let you try just see and experience what I'm trying out here. So enjoy the models.
I left my heart in California. I let it go deep into the blue. I could be happy in California. I would be fine with just me and you. Now don't go changing your heart. We gotta keep the blue. We gotta keep the blue. Lion heart, you got me feeling like the queen of Mars. You're giving me the double boom to my heart. You got me screaming with my hands to the gods. Ooh, lion heart, lion heart. I lost my mind in your dreamy eyes, and I let my pride go by the shore. Now at a blue moon and under dark skies, I keep on crying.
So again, just summarizing the video, this system, my review of the Sinterit Lisa system is just, I'm kind of blown away how much you get for the system. It is a little bit of a start of a process, of course. It's not like the FDMs that we're used to, but I don't think it's that far from SLA or DLP printing. where you have also gloves and you have parts that you need to fix, and there's a lot of work around it. So I think it's actually quite comparable to the process of a SLA or DLP printer. It's a little bit more, and it's also a little bit longer printing times because of the heat up and the slowdown of the heating as well. But what is really important to remember is that if you're doing work, maybe you have this as a production tool at your company, or you are a small or medium-sized production or prototyping plants, you can stack a lot of models. So it doesn't really make any bigger time differences if you have like filling all the X and Y axis of the model. It takes a little bit extra time, of course, but you can stack the whole model and print over a weekend, and then you're good to go on Monday. So you have a lot of prints being able to stack not only in X and Y, but also in the Z axis. And that is one of the most amazing things about the SLS printing, that you can stack it in Z axis and make freedom of design, parts that are moving inside of each other, turnable wheels, for example, all of these kind of stuff. It's just up here. That's what's limiting you. So I think it's amazing. I would love to have one at home, not because I might print a lot like for home stuff, but the ability to actually do useful parts that are strong, that are working, that can handle some temperatures, and to do that with the price that the Lisa system is, that's kind of unheard of today. So compared to other released machines and other solutions out on the market today, I think it's unbeatable. Today, we'll see where we're at in 6 months or a half year, or yeah, that's the same, Anton, in 1 year or 2 years or more. But at this very moment, I don't think you can get any more value for money if you're looking for SLS system. So with that said, I think you guys should check out the video links down below, because there are some very long but very interesting interviews with some of the people over at Sinterits. And you should also subscribe, because, you know, maybe we'll do some more fun stuff like this at some other companies. We'll see. Everything's possible if we let them invite us. So thank you so much for watching. I really hope you enjoyed this video. Let me know down below if you have any questions, comments, thought about what is SLS. Of course, you should already know that, but if you have anything you want to share, let me know. I'll take it with the Sinterit guys, and maybe they'll even spend some time in the comments down below as well. So yeah, thank you so much for sticking around for this long video, and I'll see you guys in the next video. Bye.